There's an animal on Earth that weighs nearly half a ton, is armed with rotating hooks instead of ordinary suckers, and can kill prey several times the size of a human. And despite all that, we still barely know how it lives, which is strange. We can land a rover on another planet, map the surface of the moon down to a few meters, and observe black holes millions of light years away. But when it comes to the colossal squid, most of what we know starts with the words probably or most likely. The reason is simple. It almost never comes up to where we can be. The colossal squid lives at depths of around 2 kilometers. That's a place sunlight never reaches. Pressure there exceeds 200 atmospheres. Send a regular underwater camera down and it becomes a crushed piece of metal. Even specialized deep-sea vehicles operate at the limit of what they're built for, and every expedition costs millions of dollars and guarantees nothing. So almost everything we know about this animal came to us by accident. One specimen got caught in a fishing net. Another turned up inside a sperm whale's stomach. Somewhere a single tentacle was recovered. Somewhere else, a beak that hadn't fully digested. Imagine being asked to describe a lion, but instead of an actual lion, you're given a few bones, a patch of skin, and a couple of tracks in the dirt. That's roughly what studying the colossal squid looks like today. And the most interesting part starts right there, because the more scientists learn about Mesonychoteuthis hamiltoni, the less it resembles an ordinary squid. It's essentially a completely different survival machine, one built for a world humans will never see with their own eyes. If you look at other large squids, the differences might seem minor at first. Long body, 8 arms, 2 tentacles, a beak. Broadly the same. But the deeper scientists got into the colossal squid's anatomy, the more they kept finding things that either don't exist in other species at all or are nowhere near as developed, which makes sense. The environment it lives in leaves almost no room for mistakes. Near the surface, a fish can miss a target and find another one minutes later. A shark can circle back and try again. Even a lion rarely faces starvation after a failed hunt. Another chance comes along. The colossal squid almost certainly doesn't have that luxury. At depths of several kilometers, life is sparse. There are no massive schools of fish drifting by. Nobody knows the exact numbers, but most biologists agree on one thing. Encounters with substantial prey happen far less often than in the upper ocean, which means every mistake costs a lot more. Imagine being allowed only a handful of attempts to eat per month. Suddenly it makes sense why evolution didn't cut corners on the weapons. That's why the colossal squid looks like something an engineer designed, rather than something that just happened. Longer tentacles, denser muscle, a bigger beak, more complex hooks. All of it raises the cost of building the body. More energy goes into making it, but if each successful hunt pays for those costs, the strategy works. There's another detail that puzzled researchers for a long time. When the first specimens reached scientists, many expected to see a giant version of an ordinary squid. What they got instead was an animal with certain features so overdeveloped they required separate explanation. The most famous example, the eyes. They're so large they were long considered the biggest eyes in the entire animal kingdom. Diameter around 30 centimeters, bigger and larger individuals, about the size of a soccer ball. And that size didn't happen by chance. The paradox is that it lives somewhere with almost no light. You'd think huge eyes would be useless there. But it's exactly the opposite. The less light there is, the more valuable each individual photon becomes. A bigger eye collects more light than a smaller one. Sometimes that difference is enough to make out the silhouette of another animal dozens of meters away. To us, that sounds almost laughable. For something living in total darkness, it could be the difference between a meal and starvation. But here's what's interesting. All that hardware, the hooks, the eyes, the beak, is probably used very rarely because the colossal squid, as best we can tell, spends most of its life barely moving. That sounds odd for an animal this size, but it has a reason. Its fins are small, comically small relative to its body. It wasn't built for pursuit. It can't chase prey across long distances the way a tuna or shark can. Its muscles work differently, designed for a short burst, not a sustained effort. So it probably just hangs in the water column and waits. That's ambush hunting. Minimum movement, minimum energy. You don't spend what you can't replace. There's another detail that fits this picture. Its muscle tissue contains ammonium chloride. Ammonium is lighter than seawater. It acts as a kind of biological ballast. It keeps the animal at depth without spending energy to stay there. No fighting gravity, no fighting buoyancy. Fish solved the same problem with the swim bladder. The squid took a different route, cheaper in energy terms, but with a side effect. The flesh smells like ammonia, and by all accounts tastes terrible, which is why nobody seriously fishes for it commercially. The few that were accidentally caught weren't really eaten. Now, the sperm whales. They're the only known predator that hunts the colossal squid with any regularity. Though regularity is a generous word here. Mesonychoteuthis beaks have been found in sperm whale stomachs. That means encounters happen. But nobody has ever seen one. What we have seen are the marks left behind. Circular scars on sperm whale skin. Impressions from hooks. The squid fights back. And judging by the size of the scars on some individuals, it fights back hard. A sperm whale weighs up to 50 tons. The colossal squid, half a ton. 100 to 1 difference, and it still leaves marks. That's not evidence the squid wins. It doesn't, but it doesn't go quietly either. Scientists have debated for a long time exactly how this hunt plays out. The sperm whale dives deep, down to 2 kilometers or more, holding its breath for up to an hour. That alone is extraordinary. But what happens after that, we barely know. Is the whale blind in the dark? No. It uses echolocation, clicking, listening for the return signal, building a picture of the space around it. It literally sees with sound, so the squid isn't invisible. The whale finds it, but the squid almost certainly knows it's coming, because echolocation pulses are pressure waves moving through water, and the colossal squid has statocysts, organs that detect changes in pressure and vibration. It senses the whale approaching, not with ears, with its entire body. What happens next is mostly guesswork. Either the squid tries to run, a sudden burst of speed, a cloud of ink, and it disappears into the dark. Or, if there's nowhere to go, it turns around, hooks forward, and the whale gets what later shows up as scars. But the ending is almost always the same. The whale is bigger, much bigger, and it has teeth. The best the squid can do is make itself expensive to catch. Judging by the scars, it sometimes succeeds. Now about size, because it's more complicated than it sounds. When people say half a ton and the world's largest squid, that sounds clear enough. But the truth is we don't have a single complete adult specimen that reached scientists in decent condition. Every recovered individual has been either young, dead, or partially digested. An animal that dies 2 kilometers underwater just stays there. Nobody retrieves it. The ones that reach the surface are the ones that got snagged in a net by accident or got vomited up from inside a whale. This matters because it means we don't actually know how large they can get. What we have are beaks. A beak is the hard part. It doesn't digest. You can estimate the animal's size from it, and some beaks found inside sperm whale stomachs were noticeably larger than the beaks of any specimen ever caught. That means one thing. Somewhere out there are individuals bigger than anything we've seen. How much bigger? Unknown. Maybe a little, maybe significantly. We don't have the data to say. Then there's reproduction. How they do it, we don't know. That's not a simplification. There are no observations of colossal squid mating. No records. Not even indirect data from which anyone could confidently reconstruct the process. Other squids have known patterns. The male delivers spermatophores, packaged capsules of sperm, sometimes directly implanted into the female's body. It sounds rough, but among cephalopods it's standard. For the colossal squid, something similar is probably the case. Males have the relevant anatomy, but the knowledge stops there. How long they live? Also unclear. Estimated at several years. Some data suggests up to 5. For an animal this size, that's remarkably short. Whales live for decades. Sharks too. But the colossal squid may grow to half a ton in 4 or 5 years and then die. If that's true, its growth rate must be extraordinary. For comparison, a human child over 5 years reaches roughly 15 kilograms. The colossal squid, in the same time, possibly gains 500. That's not just fast, it may be one of the fastest growth rates of any large animal on the planet. There's one more thing that's hard to wrap your head around. There are a lot of them. Not in the sense that you'd come across one easily, but sperm whales eat them constantly. Studies of whale stomach contents show Mesinicoteuthis is a significant part of their diet, and there are thousands of sperm whales in the Southern Ocean. Simple math, if each whale eats several colossal squids per year, the population has to be large enough to sustain that. Otherwise, they'd already be gone. Which means that somewhere, at 2 kilometers down, in the dark, under 200 atmospheres of pressure, in complete silence, there are a lot of them. We just never see them. That reframes the ocean a bit. You stand on a shore or the deck of a ship and the surface looks empty. Calm. Maybe some fish, maybe some jellyfish, but 2 kilometers below that surface, right now, there are hundreds or thousands of creatures with hooks instead of suckers and eyes the size of your head. They've always been there. We just found out recently. The first scientific description of the species appeared in 1925, and it was based on 2 tentacles found inside a sperm whale's stomach. Not a whole animal, 2 tentacles. A new species was described from that, Mesinicoteuthis hamiltoni. And that was it. The following decades added almost nothing. The first reasonably complete specimen wasn't recovered until 1981, by accident. A fishing vessel in Antarctic waters. The net wasn't targeting squid. The squid was just somewhere it shouldn't have been. Since then, only a handful of similar cases. Every single one. An accident. No targeted expedition has ever come back with a live specimen, or even a fresh one. That says something important about how our knowledge of the deep ocean actually works. We know what we've accidentally been shown. Everything else is reconstruction, from fragments, from scars on whale skin, from beaks found in other animals' stomachs. Last thing, the colossal squid lives in what biologists call the twilight zone and the midnight zone. Below 200 meters, light fades gradually. Past 1,000, it's gone entirely. In those layers live things we know even less about. Fish with bioluminescence. Worms several meters long. Jellyfish that glow in the dark. Organisms that feed on what drifts down from above. Remains, organic matter, whatever sinks. It's an entire ecosystem. Large, old, complex. And the colossal squid is one of its apex predators, not an anomaly. A piece of a system that runs without us and without our light. The problem isn't that we can't get there. Technically we can, it's just expensive and difficult. The problem is that when a vehicle does go down, the animals avoid it. The camera light, the engine noise, the vibration, it clears the area of exactly what we're trying to see. We show up and the place empties. It's like trying to study the nightlife of a forest by turning on every floodlight and running a generator. So the answer to the question, what are your chances against the colossal squid, is a strange one. Not because the chances are zero, but because a real encounter, or on its terms and its conditions, is essentially impossible. It lives where you'll never go. It sees in darkness that would kill you. It holds pressure that would crush you in seconds. 0% isn't a threat, it's just physics.